Hi guys, so we're back with another video tutorial. This time we're gonna be going on with sphere slices. We're gonna be probably, um, we're surely gonna be changing this. So instead of being cut, this being a sphere cut into two planes that are parallel, they're not gonna be parallel. But also we are gonna be possibly starting the work in the with the procedural textures for these. We'll see if we got time. Let's tackle first the um, the non-parallel plane cutting for this. So in order to do that, well, we could have different ways, no? But one of the simplest and easiest way that I can think of is setting two pitches. So I mean, we could cut with a with an parallel plane, but that's gonna be we're gonna have to do quite a bit of calcs. So we're gonna have to calculate the intersection between the sphere and the plane for each of the points that we have, and then recalculate those with with we have to get the plane, calculate the intersection at a given for a given section of the sphere, and then for the two planes, and then we then interpolate those two using spherical coordinates. That would be an option, but that's complex and long to implement. A simpler option would be to say, okay, instead of having one pitch up and one pitch down, let's have two. One pitch here and one pitch here, and then one pitch here and one pitch there. Let's do it and let's see what happens, okay? So instead of having MiniPitch, we're going to have MiniPitch 1 and MiniPitch 2 and MaxPitch 1 and MaxPitch 2. Actually, let's leave it like this, yeah. So, this is going to be 1, 1, 1, 2, and 2. Okay. So, the scene UI, we're going to have pitch 1. So, for the time being, this is not going to be very useful. But anyway, we're going to be using this. We can actually do it twice with match 2, 2, and this. So yeah, with this we could kind of use different color. Yeah, and that makes number 1, number 2. But it's not going to be okay, but it's not going to be showing us what we're going to be doing. But for the time being, we're going to use this. Maybe later I'll do something else. So in here, again, we cannot calculate the pitch here, and we cannot, because the pitch depends on the yaw. So basically, from 0 to pi degrees or pi rads, so 180 degrees is gonna be 1, and then we're gonna so 0 is gonna be min pitch 1 and max pitch 1, and 180 degrees is gonna be min pitch 2 and max pitch 2. So we have to first calculate the yaw angle, then the pitch angle, which is gonna be, this is gonna be correct. This is gonna be shared. This is gonna be, so third min pitch is gonna be lerp. So yaw t is gonna be if t yaw is from 0 to 0.5, it's gonna be, so t yaw lower than 0.5 f, it's gonna be 2.0 times t yaw. Otherwise it's gonna be 2.0 times t 1.0 minus t yaw. Yeah. Then we interpolate min pitch 1, min pitch 2, pitch yaw t, max pitch 1, max pitch 1. Okay, so now we got a min pitch and a max pitch, and then we got the pitch, the actual pitch that we have to use here. And the rest is correct, and it should be all the same. So let's see what happens when we do this. So let's remove these two, and this one we're gonna remove. So yeah, sphere slice 1, let's use the full material. Yeah, it starts to work. The problem is it is not actually, I mean, it's doing these like pointy things here. You see, it's like there and there, it's pointing, which is not nice. That's the reason for this is because we are doing an interpolation that is linear instead of using something based on the angle. So in order to fix this, we need to use the angle. So we have to convert this linear interpolation to interpolation based on the angle, which actually so if you think about it, let's from the top, you've got these two, okay, you look at it like that, it shouldn't do like this, it shouldn't do this shape. This is because we're moving linearly when we are using the angle. Instead, we should move, we should see a line here. That means that if this is representing the the cosine of the angle, assuming this is 0. So you see it's from the center, you got this angle, which is going to be 0, and all the way here, which is going to be 180 degrees, and here you start with a cosine that is 1, and then with -1, which makes sense. Then we use the cosine of the angle to interpolate the value of the pitch. So basically, we calculate the yaw. Instead of using this pitch yaw, we're gonna be using the yaw angle with a cosine. So yaw t is gonna be cosine yaw. Okay, let's copy this here. We got the cosine here. Sorry. So the cosine of the yaw, but the problem is we don't want only the cosine of the yaw. We want it, the cosine of the yaw goes from -1 to 1. So we want it to be 2.0 times that plus 1.0. Actually, this is not exactly what it's gonna, it should be, well, anyway, yeah. So let's remove it. Let's try if this works, and let's see if this works. Alright, sphere slice 1. Material here. Wow, something wrong. There is something quite weird here. Something quite weird happened here. So for starters, it should be a -1 here to make it so that the big part is here and the lower part is here, which is what we had before. The yaw starts at 0, so the of the yaw is going to be 1, and then it's -1, and then it goes back to 1. Let's do it again. So I'm not sure. Maybe I should be using the sine instead of the cosine. Let's just get material. The cosine of the yaw should start at 0, and what is the problem here? Why isn't it working? One, that's all right, the first time. Next time is something smaller. Oh, but this is always going to be negative. And this is, yeah, this is not right. This is, I'm sorry, this is not right. That's the problem. So, it shouldn't be 2.0, it should be 0.0. It's +1. That will be. Let's see what happens when we do this. Now, screw that. Get this. Yeah, that is better. That is exactly what we're looking for. Thing is, I was expecting it to be the long part here and the small part here. It's not that this is a big deal, but in order to do that, we probably we need to do something like, so if we like the starting 0, maybe something like 1 minus, like something like this, yeah. Yeah, damn it, I forgot to put the material, which is good. So to put in the material, the valid material here is good because it gives us the nice, sorry, we can see here the nice smooth surface and shading, which means that we are doing the normals right, and that it looks the way it has to look. So yeah, we have yep, this is exactly what we're looking for, right? Great. Let's make the pre-visualization a little bit more useful. It's not like a big deal, but I think this is just not useful at all. So we got this iteration here. We're gonna have, I'm gonna copy it, or yeah, I'm gonna copy it. I mean, we could reuse this, but it's not, it doesn't make a lot of sense to reuse it for debug drawing, and it is a lot of work to reuse this. And actually, we're not gonna be doing it. We're not gonna be doing it all twice. It's gonna be this. We just want the first and the last slides, right? So T pitch is gonna be 0.0 f. So instead of having min pitch and max pitch, we're gonna go min pitch 1. Sorry, we're gonna be doing to pitch 1 is gonna be min pitch 1. Max pitch 1. So, yeah, min pitch 1, max pitch 1, pitch. So, and this is going to be pitch 1, and pitch 2 is going to be mid pitch 2, max pitch 2, pitch jotty. Yep. Is it? So, sine pitch 1. The same with 2, y1, and radius 1, 1, 1, and 2, 2, 2, 2, 1, 1, 2, 2. And we're gonna call it P1 and P2. And then so if prep post valid whatever, draw it, then we need a vector 3 prep P1, vector 3 prep P2. So update the previous points. Handles, draw line, prep P1, P1, 2, P2. Whatever, we can make it. And in here we're gonna say handles, color, 0.0, 0.7, 1.0. Yeah. Let's see. Okay, not working. Don't know why. Oh yeah. Okay. So this is wrong. Min pitch 2, and this is max pitch 1. Yeah, that's it. So here we go. This is now clearly calculating the angles, and you can clearly see that this is not 100% accurate, but yeah, or is it? I don't know. 5, 20, 30, and yeah. So we are saying, yeah, this is not 100% right, or is it? I don't know. But anyway, this is looking good. This is looking exactly the way we wanted it to look. Good. So what are we gonna do with this? Well, we're gonna need textures to render this. So the next step probably would be to generate the textures. But this video is getting too long, so I think we're gonna leave it for the next one. I'm gonna remove this one, and I'm gonna remove this one, and with this. And even so, I'm gonna create a new sphere slice. It's gonna be correct. One. We're gonna start in MiniPitch angle. Something like this. That looks good, but it's too small. So 20, no, 30, 15, 30. Yeah, this is better. Yep. So yeah, that's a valid one. We could even have it a little bit bigger. Yeah, better. Still not 100% accurate, because this should be a plane that cuts, but anyway, we're not gonna be doing anything about that. So so this is gonna be it for this video. We're gonna be doing the textures next, and after that we will generate a bunch of these, and we'll make an algorithm so that the boards choose some of these randomly and give them random rotations when being created or when being resetted. But first we'll do the textures, because that's gonna be interesting. This is something we haven't done so far. As usual, if you like this video, please hit the like button, and any questions, leave them in the comments below. I hope to see you guys in the next video. Bye.